I think we'll start. Hi, everyone. But now I lost you, Michael. You stopped sharing? You have stopped sharing, I think.
Well, I'm here.
You're here. This is going to be lovely to edit. Okay, I think we'll start. Now we see you. No slides then. We won't touch anything until we connect again. Okay, so hi, everyone. Thanks for joining us today for this Find Your Way in Zoom thing. We're going to talk about what are we going to talk about? Model-based testing today. And with me is Michael. So Michael Bar-Sinai from Provengo. So why don't you introduce yourself first?
Hi, so I'm Michael Bar-Sinai. I'm a co-founder and CTO at Provengo, and we do model-based testing tools for to democratize this to the mainstream engineering area. So yeah.
Okay, that's a short introduction. So while we're going to talk more in depth about what we do.
I have a long deal.
Yeah. So yeah, we'll talk about that. My name is Gil Zilberfeld. I'm from Testing Gil. I'm a consultant and trainer about all things testing and development. And I'm very excited to talk about model-based testing today because I think as you'll see, we're going to talk about this and we're going to show you what Provengo is working on. This is something that's very near and dear to my heart, which is not just testing. It just like encompasses the entire development process. And basically, why are we here? Michael, what kind of problems are you trying to solve?
Right, so we're trying to solve, obviously testing, right? So creating a comprehensive and thorough sequence, and that in an easy way that's also easy to maintain, right? Because if you have a lot of tests, then normally it's great, you have great coverage, bit of problem. But as you mentioned, model-based testing, it really what it does help you and the entire team understand properly what artifact of model-based testing is obviously the model, right? Which is basically an understanding of how system. And once you have that, then a lot of things in the communication between development and product and QA, you all speak the same system, the same language. You all look at the same artifacts and understand what you need to build. So it does a lot. It does wonders to communication between teams and reduces. So it's compartmentalize it in testing, but it can also have an effect on the entire software development life cycle.
Yeah, so we've witnessed that a lot, right? So when usually people from different, we want in agile processes, people from different walks of life to work together, and we want collaboration. And today we rely a lot on documents and drawings, and not everybody sees or understands the same thing. So basically what we're trying to do in this kind of thing is to unify these things. The more people understand the same thing and from the same perspectives, we're assuming there'll be less mistakes and less bugs, right?
Right, exactly. Less communication gaps and less, oh, you wanted that. Sorry.
You can see by the faces that the surprise
at the end, or like at the delivery stage.
Yeah. Okay, so models.
Yeah.
Let's talk about models. What are models? Let's start with the basic stuff.
Let's talk. Right. So what are models? That's a good question. So it's a really a useful description of. I think the most when we use models all the time. I think the computerized model we use is maps, right? So you go to navigation, use navigation applications like Google Maps or Apple Maps or normally called maps, I guess. And suppose you want, so they describe the real world, right? If you're outside to the real world, some people still do that, I hear. There's a lot of small details, right? I mean, there's obviously roads and junctions and rivers, but so trees and bushes and dogs that walk around. And these things are normally not in the map. So if your map, which is the model here, right? The model of the outside world, is say based geared towards right, you go to the then you use a map that will have junction stations, obviously, waterfronts or where you can wait in the shade of the place. Lovely. Okay, so yeah, we're just walking our dog, right? So when you, if your the use of the map is to find a good path to walk your dog, then you'll use the details, right? So the model here, which is a map, is it's really a simplified description of the real world. It doesn't contain all the details, it contains the details you need, right? For model-based testing, that would generally be the same, right? So you try to model the way it behaves or should behave, required behavior, and then derive test cases from that description in the same way that derive paths to the nearest train station from model, right? So this is the idea. From this comes a lot of benefits, because not just because a lot of tests, but the same and going and planning your driving route, just create to hold a map of how the application should behave gives you a lot of advantages, because for going back to the map example, you don't just go to a single train station. You can ask which are the possible train station I can go to, or how can the traffic jams or stuff like that. So you can basically query the model and come.
This is going to be a lot of fun today.
Yeah, I think I like that the technical difficulties are because they're not, but we don't care. We can
it's a great way to pass the time. Technical difficulties.
Yes, exactly. It's like an escape room, but in Zoom management.
Okay, so we talked about models.
So again, once you hold the model,
yeah. So we're talking about models that first kind of have the information that we need.
Exactly. So they have the information that we need, and then we can derive solutions out of this information.
Okay. Okay, so we kind of use models all the time, right? Like maps, even while we're testing, we have a model in our head of how this is supposed to be. It's not necessarily about how it's built or how the user will actually do that, but we have some kind of expectations of workflows and what's going to happen next, because we read that in a document and somebody told us that this is how it's supposed to work, right?
Exactly.
Okay, so now what you said is like, let's try to build a model that contains everything, and if everybody sees perspectives of that, it doesn't even matter. But if the source is one, then we're also already trying to eliminate all kinds of misunderstanding and conflicts.
Exactly, because now all the model itself, because it's a computerized thing, right? It's not just a normal a Word document that really doesn't fight back, right? You can write whatever you want. Here, this is a model, and you can query things. You can draw it, for example. You can generate drawings of possible business flows, and you can validate basically that your understanding is the same understanding as the products or as the developer.
Okay, so once you have this, there's something very interesting that you said. Until like today, before everybody sees what you're doing, the understanding and what's really our expectations, the behavior that we want to see and the results that we want to see are interpreted by our brains. And my brain is not like your brain. So it's going to be like different interpretations, different expectations. And therefore, there's going to be, again, it's leading to this kind of not the same understanding and so on. A computer can do two things. First of all, it can unify these things. But a bit more than that, it can hold in its head, whatever its head is, a lot more details, right? And it can find things that, for example, in the model, the requirements, if we're starting from that are wrong, but other people may miss that, right?
Exactly. And you can also even computationally say forbid things from happening. Say, for example, it shouldn't be possible for, say, an underage person to apply for a credit card, for example. And if you allow this by some change of introducing new requirement like fast issuance or something like that, and you're missing this check, then the model would actually complain.
So you find the errors early, right?
Exactly. This is shift left, but like all the way left. So you basically, for some cases, but some common cases, you can actually check the requirements before the application is even built.
Okay, so if we use that, what are the implications day to day? So if there is this one model in the sky, one big model in the sky.
Yes. So how first of all, the way that you normally work, right, as a QA person, normally you gather requirements. I know that like in your organization, obviously everything comes up in a very tidy and well understood with no ambiguities, but some organizations I hear are kind of like, you get an issue with just the title. So we need to do that as well, and you need to gather the requirements, right, to understand what you're checking to begin with. And once you have this understanding, you start writing tests or test scenarios, and then sometimes you have test readiness reviews or things like that. But you basically come up with a test plan, and hopefully, and it kind of it reflects the way you understood what should happen. But this understanding is not concrete. It's like it's reflected by the tests. And you give someone 300 tests, like the product, you give them 300 tests, they normally would look at the first 2 or 3, and then we're like, yeah, looks fine. Now, if you use model-based testing, your understanding, instead of communicating or giving the computer just a set of test cases, basically, just a list of steps, what you give the computer is your understanding of the requirements, right? You basically build the model. And this model can be visualized. So you can basically visualize it, and we're going to see it soon. You just visualize it, show it to even to non-technical people, because it's just errors, right? Errors and things that happen on them. And they can validate that you understood what they meant. And also, that's I don't know how many product people are here, but also they can validate what they meant, which quite often, there's some, it looks fine in their head. This happens to everyone, right? It happens to me as well. So
it sounds good, and you start doing it, and then you realize it makes no sense, like a few steps into the project. And it's a very early way of getting some tangible products out of the requirements. Really, they basically can look at the screen and say, well, this arrow here, we shouldn't allow this business process. This makes no sense. So that's one change, right? So you're starting to use the computer much earlier, the power of the computer much earlier, not just for creating the scenarios, but actually creating the model, to create the model. Next up is, generating test suites becomes very easy. Just tell the computer, okay, you have this model. Now I want to generate, I don't know, 500 tests that focus on these area, right? Because again, this is, so I think back to the maps, right? You can say, I want to go from my home to this train station, and I also want to go through a roundabout, or I want to go through 3 traffic lights or something like that, right? So this is the, you can do the same thing with possible test scenarios, because a model basically holds all possible test scenarios given a behavior, right? So you can just generate these tests. If a requirement change comes along, you don't have to go through all your test scenarios and see which one is affected and how. You just throw all the test scenarios, the old test scenarios, you update the model, and then regenerate the test. So maintenance basically goes down by a lot. Really.
So really, we're starting with a validated model, right? One where everybody agrees on, and this is kind of a different way than we usually think, right? We usually think that, well, requirements change. Obviously, they slip down to development and testing and so on. The changes, and then we need to see what are the differences. But a lot of the time we're trying to think and reflect on what we're not supposed to change, what should change by but a little. So we do all kinds of sort of math in our head, or list management. And this time, and in this method, it's a bit different, because if everybody agrees on the changes, the generated tests will have the truth in them, right?
Right.
Again, exactly. Immediately.
Yes. So your tests are basically correct or aligned with the requirements by design, really.
It's interesting. Okay, so I guess we can, if you can show us how it looks like, it would be nice. Can you?
Well,
it's a challenge today.
I know. Let's see. So, yeah, let's look at some requirements. Do you see things change?
I saw things change. Yes.
You saw things. Yeah, we're all about change today. Okay. So what we're going to do is to, as a test case, right? We're going to automate this little website here. It's a morning routine simulator. I think we came up with this example after some hard morning throwing the kids to school. But this is, it should be a familiar example, right? So I have this morning, this kid here, and it's morning, so they need to wear socks and shirts and maybe shoes and put some pants on, eat their cereal, brush their teeth, and tidy up a bit, and then go out. Okay, so it's a website, and we need to simulate it. We need to check all possible, or at least consider all possible ways of doing the morning routine. So this is what we're going to automate. And to do this, we have this model here. So a model currently, I mean, we have some low code, which we'll see later. There's some no code, but for now we'll use simple code. Okay, so I'm going to, for the sake of brevity, skip all this B thread and requests and stuff, and just go with the actions. Okay, it's not complex, but it's not a tutorial, right? I mean, it's just what MBT can do. Model-based testing can do. So this is the main story. right? We wake up, we wear pants, shirts, socks, and shoes at any order, any possible order. Okay, that's important. Then we brush teeth, we tidy up, and we go out. Okay, quite easy. So I can now, for example, I can run this. This still does not have automation. We'll see automation soon, but if I run this, you can see that it picked some order of shoes, shirts, and socks and everything, and it went out. So that's easy, right? This is something we can do with any programming language. But what we can do with the model-based systems is not running it, which is again nice. What we can do is draw it. But because this is a model, because it is a useful description of something, we can basically take you can draw it, right? And this is something you can take to a business person. Each route here, right? Each test case, if you will, starts here at the start, and then goes out. Whatever.
So
And
we
then,
had like a whole process of getting the kids in order in the morning, but
right.
the different forks in the road are different options of things they can do.
Exactly. So yes, so you have, for example, here you can see you wake up and then you can either wear your pants or shirt or shoes or socks. So there's a lot of options, but eventually there's a lot of paths here, but eventually you brush your teeth, tidy up, and go out. So this is the beginning. Okay, so now, for example, going back to the model now, you know, someone can say, you know, maybe the kid is really woke up late or something, and maybe he would go out and tidy up like on the bus, right? So we could add things. So this would be an example for a model requirement, business logic change, right? So I'm going to add this late thing, right? So if we're late, and this is something that you wouldn't see normally in any testing framework that's not model-based, really. This one is going to split the test into two. We're going to split the scenarios, and if we're late, then we go out and then tidy up. Otherwise, we just do it normally, right? So we go from this type of model. Okay, so where this is very linear, right? I'm going to analyze this again. And now we can see that we have, at the end, we're splitting into two scenarios, one that where we're late and one where we're not. Okay, so this allows you to get a very thorough coverage of things. And you can also see that it's very easy to adjust. Like, we had this requirement, we added things, and now it's working. So let's assume that we're not late, but look at breakfast, okay? Okay, so
so the idea, first of all, is to have like a description of the model in different scenarios, and then the computer behind, the brains behind that, understands the different paths and understands what can be done and what cannot be done. Really.
Exactly. And then all the changes, again, it's very malleable, right? You just regenerate what you need. So let's make this less of a toy example. We have breakfast, and there's different type of breakfasts, and for each type of breakfast we eat different things at different orders. Okay, so again, I'm just to so I've commented in these options, and now we have, if I again run this, we can see that we have this is the area where we dress up, and this is the area where we do breakfast. And now the next thing.
So when we're talking about more complex things, it's going to be like a wall-size picture, right?
Right. So first of all, there's a lot of things you can play with. For example, so this might be easier to draw it like this, for example. But yes, it can become very big. But again, once you get to the details level, you probably wouldn't need this kind of drawings. You'd use different methods. But also, normally when it becomes very big, it's because of automation, which is what we're going to do now. And these are less interesting for product people normally. So if you're going to validate your model with some business person, they wouldn't really care about how you click certain XPaths or stuff. Okay, so now let's throw in the modeling and the automation layer. Okay, so I bring in these two things, and what they do again is just detailing the model, right? As we mentioned before, going back to omitted details. Now we add the details that are interesting for us, because now we want to do automation. So for automation, we actually have this Selenium session here, and we're going to use Firefox, and we have all these XPaths, and we wait for visibility of things. So we've added this, and we're going to run this, but first I want to analyze it again, just so we see the new model. This is a bit bigger, but you can see that really we have, for example, we decided to wear shirt, right? So this is the business decision. And this is the automation that's implied by this decision, right? So we click and then we wait for visibility.
So basically, this is a translation of the model from the requirements to the UI definition of the screen, right? When the exact details of buttons and labels.
Exactly. And I think you can just put in and put out easily, right? So for example, here we do the text assertion, right? Here we decided to eat egg here. This is the business description. And now we add the text for eating egg, and we validate that the label is updated correctly. So we basically added an actuation layer, what's known as an actuation layer, from the model, from the business to, in this case, website, right? So Selenium-based website, but it can be Appium, it can be command line, it can be, REST APIs. It's very easy to change the actuation layer because it's all pluggable, right?
So actuation means finding and clicking stuff and reading what the values are, right?
Exactly. Yeah. Normally automation, what you'd normally call automation. It's just you decided what's the business scenario, and now you automate some systems in order to execute the scenario and see that it happens. Just to show automation.
So if I compare it to like while you're doing it, if I compare it to like manual testing, that means that we're translating in our mind the processes into buttons and stuff like that, or in APIs, calling the APIs. And here is basically the translation is sort of automatic, right? After you give it enough data.
Exactly. It's automatic. And finally, you mentioned manual testing. It can also generate manual test books, because it can translate a business decision to instructions for a manual tester. So you can actually have automation people creating manual tests automatically, which is that's the new world, which is weird, but it's better than no one. Okay, so let's do automation once. I mean, this is just for I don't know, just to show the thing. I mean, we've all seen automation before. So I'm just telling it to run something once. We can obviously do more than that. Okay. Okay, now it generates, obviously, I'll open this in a different window. Okay, so it chose some path, and now it's doing.
So it's now running the actual application. It's not something
exactly.
based on what it gave it as the model. But
Exactly.
understood that's a model.
Exactly. What it did was basically select a path, a random path here, starting from here. And suppose it decided to go with the socks first, and then shirt, etc. So it just chose a path from here to all the way here, executed it, recorded the screen and everything. So,
and you can take that and modify that for more specific, like asserts or expectations, right?
exactly, yeah. You can make it as detailed as you want. But I want to focus less on automation at this point, because it's something we've all seen, right? And let's look at assertions, right? Because one of the things I mentioned was the fact that you can actually check the requirements, and we actually have a bug here. I'm going to throw this thing out for a second. And the bug being the fact that it's a bug in the requirements, really. So there's a weird case here where you can actually wear your shoes and only wear your socks later, right? Because we said here that we can request these actions, this wearing things actions at any order. And some orders don't make sense. So what we can do is, first of all, detect this, right? Protect ourselves from errors in the requirements. And we can do this by adding this negative scenario, really. It basically, what we do is we wait for someone to wear the shoes and then wear the socks. And then we say, it's like, you don't wear socks. You can't wear socks after you wear shoes. This is a bad, there's something in the requirements don't make sense. This is where you won't call the developer and tell them that you found the bug. You go to the business, to your client or to the product.
So this is a constraint in the requirements, right? It can do anything else, but this must be according to this condition.
Exactly. You can think of it as even a query to a database containing all possible tests, saying, give me all the tests where you wear shoes and only then you wear socks. If you found, a single test or more, then the requirements are wrong. If I analyze this one again, you can see that it found those cases. And not only did it find these cases, it was also able to say what was the problem, right? It's not just we have a problem, right? This is the problem, and also you can see the path to get to the problem, right? You wake up. It's always a bad idea, by the way. Wake up in the morning, wear pants, shirt, shoes, and then socks, then, right? So you can actually come to the product and tell him, this is how you create the bug, or this is how you go through the loophole that the requirements have left. So once you have this, now in this is just checking that the requirements are fine, but you can also do what we call rainy day checks, right? So when you say, as a tester, right, you say that you can't wear shoes before you wore your socks. This can mean a few things, right? This can mean that don't even bother testing it, because that's just not going to happen. We can assume it's not happening because maybe some other system is, imposing this constraint. Or you can, it might mean that you want to test this and make sure that it fails, right? So the user try to click the button and get a nice error message. So we can do both, obviously, and let's do both. So basically, I mean, we can look at the code itself, but basically what we do is kind of assume that these things won't happen. And then we basically say don't wear shoes, before you wear socks, etc. Once we do this, we get different model where first of all the tests are fine. You can see that here, for example, right, we start with wearing shirts, wearing pants, wearing socks, or failing to wear shoes. And on the other side of the model, here, you can decide if we have breakfast or not, and we can fail wearing socks. Now that after the shoes, we wore shoes somewhere here, we can fail wearing socks, but we didn't say when to fail wearing socks. So we have this large set of possible tests here, where you can eat egg and then fail wearing socks, or maybe you can try to do a few other things like eat banana, eat cereal, and then fail with your socks. So you get all possible tests. Again, you don't have to execute them, but they're there, right?
Okay, so this this looks already complex, right? But you have run it on actual complex software in the wild, right?
Yes. We've seen it running in the insurance companies, which have larger. An insurance policy is more complex than waking up in the morning and eating something. We've seen it in banks. We've seen it. So it's something that we've seen working, and also more importantly, because these systems are so complex, it's a question of how do you properly tested them, right? So you need to select some optimized test suite that say, if I run these 5 tests, I run these 10 tests, or maybe 100, I don't know, but how do I know that system is properly covered? And again, once you have a model, you can basically tell the computer to do this for you, right? So a simple way of doing this here, for example, is setting goals. So I can tell the system, look, I want a test suite that would cover the following actions. I want to check that we're going out. I want to check eating cereal, eating banana. I want to check eating a healthy breakfast, and I want to check skipping breakfast. Okay, this is a good. This would be a good test suite, and it's obviously, I mean, it's different, right? Different test suites have different goals at different appropriate test suites, right? I mean, if you're doing a regression test, is different than if you're checking a new area you want to focus on. So I'm not going to run this. I have something prepared. So this is we've seen this before, right? This is the action here. This is the all possible tests. And what I did was basically tell the computer to select a set of a test suite, basically, that would cover all these goals. Now, normally there are 5 goals here, so you'd think you'd cover it with 5 tests, which is correct. But you can actually cover it with less, because not all of them are mutually exclusive. And it's very easy to optimize. So I played with it a bit, and I found out that I can cover this with 3 goals, right? So this is superimposing it, right? So given these 3 test scenarios, I cover all the goals that I need. And this is all computationally done. I mean, I just played with it. I didn't do anything. I mean, there's no heroic right stories of how I build this. There's just basically a few commands in the command line telling Provengo to cover this for me, and that's it. And I have this test suite, and I can do whatever I want with this now. For example, I can let's see if this works. It does. So for example, I can generate a manual test book out of it, right? So and because the system generates the book, it also knows what choices it made on the way. So we can filter those where we cases where we have breakfast or when we don't have breakfast, and cases where we check if we fail with the socks or not, and breakfast types and stuff like that. And each scenario we look into it, right, is the initial parameters and things you can do with it, right? So this is one way of exporting it. I mean, if we run tests on this, so these are, I think, that's the one of tests I ran. So again, it's, doing what you'd expect, right? Running everything, checking, telling you what it did, taking screen captures. So it does all that. It can also, coming back to, we can also generate tests for third-party systems, right? So suppose you have a good Python scripts. We can, instead of translating it to manual tests, we can translate it to Python or XAML for Windows automation systems like I forget the name, but it's used in a lot of places. JSON, so you can generate any text-based thing you can generate.
Okay, I think we're starting to run out of time. I want to first of all say the minimization thing is very important, right? Because we're kind of thinking of a complex system, which you can, like, in a push of a button, generate like millions of tests. Still takes time to run it, right? So if you want the feedback of running tests and see if something's working or not working, you probably won't wait for a million tests to run.
Exactly.
So
and then you try to
the optimization of what we need to run is something, again, that today we're trying to do like manually with our brains in our team, and say we don't have all this time in the world. What should we automate? What should we run manually? We skip a lot of things. But this way, let's say it's more correct, right? Because if the things that are found are equivalent, we can skip them.
Exactly. And it saves you a lot of time and also a lot of money, I guess. Once you talk about time in CI, running all these systems in the cloud is not free normally.
Yeah.
So it's save time and money and maintenance as well. I would like to add one thing, because we do a lot of effort in this area. It's not only code. I mean, we have a lot of code. Obviously, if you want to do JavaScript based, it's a very minimal way of doing JavaScript. But we also have some parts that are low code / no code. We can, if you want to parameterize test cases, we have a VS Code plugin for it, and we can also run BPMN diagrams. So it's not just for people that code. You can maybe even edit this type of diagrams with your product manager, and then use code to automate it from your side.
Okay, we didn't
just,
mention
more
that in the
things you can do.
beginning, but the input here are documents, right? Like documents, not just manually typing in the processes.
So yeah, I mean, you can put this type of documents like these tables or BPMN diagrams, and you can type code as well. There's all kind of DSLs that help you. So that's domain specific languages. So if you would like to think of your system as a state machine, for example, then there's an easy way of creating state machines. Or again, combinatorial, if you do some combinatorial test design, so that's another thing we can do.
Mm-hmm.
So there's a lot of options to create the model, and they're all interweaving, right? So you can think of part of your model, the part of your model that you can think of as a BPMN diagram, and the part that you think of as user stories would work together. So you don't have to, we don't impose any one way of thinking about the system.
Okay. The thing I like about it is not, it's a lot of things to like about it. But I think it's one of the ways to combat complexity. And I think this is one of my main interests in testing and development, because we build complex systems, right? We can't run away. It's not like, with all the challenges of getting your kid out in the morning, insurance and medical stuff, these are the things that we usually deal with. And
Right.
these are, we're fighting these like in a linear way. Well, these things are exponential. So I think that this is a good way to like at least start combating that, and we'll see how it works from there. Okay, so if people are interested, where do they need to go? Who do you want to ask? So I'll try to share my screen this time and show your contact information, and hopefully it works.
So basically, we're available at the Provengo. Oh, nice.
Oh,
Provengo.tech. We have a website there. It's contact forms, and you can obviously mail me directly. Yes, and we're starting to see the system in the wild, right? So if you're interested, if you think this can make your life better, we'll be happy to help, right? Give us a call.
Thank you. If you have any questions, put them in the Q&A box.
Oh, there's a Q&A box. It's my
Q&A.
first time as a panelist. I didn't know I need to open it. Okay. Oh.
So there are no questions yet, so we're waiting. If that's okay. If you're just like in shock of what you saw, that's okay too. So we'll wait a few more seconds. In the meantime, I'll tell you a bit about myself. That's me. If you have other testing questions, development questions, any process things that you're interested in, and not just with great tools like Provengo, but other great tools as well, you can contact me as well. Okay, so at this point, we don't have questions, and that's okay. So we'll cut it down right now. Michael, I want to thank you.
Thank you.
You're gone, so you can share now, so you can say bye to the people.
Where is it?
Yeah, I know, it's like too many buttons. Yeah,
too many buttons. Yeah, as you said, complexity is an issue.
it is.
But thanks a lot for coming, and I hope you find this interesting.
Thank you, and for me it was very interesting. Guys, thank you for coming today. You have the contact information. Thank you very much for coming today. Bye-bye.
Bye.